So we want to consider an example on the tension crack. So we want to consider solving or finding the factor of safety with and without a tension crack. So let's take this question. A cotton in a saturated clay is
The what?
inclined.
A cotton.
A cotton. Cotton. Or a cotton. In a saturated clay is inclined at a slope of 1:1.5.
A cotton.
Yes, a cotton in a saturated clay is inclined at a slope of 1:1.5.
The ratio of
Inclined at a slope of 1:1.5. It has a height of 10 meters. Full stop.
and
With an height of 10 meters. Full stop. Then continue. The bulk unit weight of the soil is 19 kilonewtons per meter cube. The bulk unit weight of the soil is 19 kilonewtons per meter cube.
okay.
And its undrained cohesion is 42 kilopascal.
The bulk unit weight
The bulk unit weight, which is C, is 19 kilonewtons per meter cube. Sorry. Bulk unit weight. While the cohesion is undrained cohesion 42 kilopascal. Can we continue? So, full stop. The question is determine the factor of safety against the immediate shear failure along the slip circle.
So, A, say
Ignoring the tension crack by using sector angle 84.06 degrees. Area of slip mass 102.1 meters square and central distance from pole 6.5
by using what? Sector.
on the board.
Yeah.
Right? There is
Okay, I'll do that.
so we're given a diagram.
That's the interpretation of the drawing.
So this drawing will be given. Yes. Because with the information we were given from the question, we can't produce this drawing. So the drawing has to be given.
The statement of the question, I want to.
The statement of the question.
What you say, just ignoring.
According to the question, it says determine the factor of safety against immediate shear failure along the slip circle. A. Ignoring the tension crack by using sector angle with 4.06.
That's the first part of the question.
Yeah, the first part of the. So this is the diagram given in the question. So from this diagram now, we don't know our
That's
radius.
that one.
Yeah, this is theta C and this is ordinary theta.
Okay.
So one is to the end of the slip circle, while the other one is to the end of the crack, the tension crack.
This is this see. Now the crack. 6.7 meter, right?
Yeah, 6.7 meters. So let's call this point O.
Yes. I'm trying to. Why your measurement of that YC?
YC.
What's below the?
Yeah, it's from here to 1/3 of this of the crack.
Under this.
Then the other one is like UW.
And that height, where is it touching? Okay, it's touching.
This one,
Okay, it's touching to this place.
yes, from this point.
And Z
Then not.
Z not. And
So-
that's where the crack is on.
Yes, this is where the crack ends.
CR. CR or what? EW. EW.
EW or OW. No. So, can we continue?
Yeah.
Okay. So, from here now, let's find our radius. So, we already know the height from this particular point to the top as 10 plus
Sorry,
6.7.
sir, please. We'll look like primary school. The first step of the question is to look for the radius.
Yes, you want to find the radius. Yes.
Yes.
Yes, using Pythagoras theorem. Okay, we can as well draw a triangle.
Out.
Yes. So we call this is our R. This place is 5, while this place is 16. So our R squared is equal to 16.7. 16.7,
That's implies school.
yes, plus 5 squared. So please, what's the value of our R? We've gotten the radius as 17.43.
17.4. Impact.
Yes, it does.
Good morning.
From here now, we can now move directly to the A part of the question to find the factor of safety, ignoring the part that there is a tension crack. And to do that, we make use of the formula factor of safety, which you can represent with FOS or F, is equal to. Remember this formula when we're dealing with the Taylor's method. C R squared theta over WX. Are you familiar with this formula?
No. What am I looking for? FOS.
Yes.
That time. That
Taylor's
time.
method, yeah, from Taylor.
Of Taylor, yes, Taylor.
Yes, Taylor.
Yes.
So, that's what we are going to do now. Because the general formula is CR squared WX plus this is the general formula. What we have up here is the general formula. But in a case whereby we are ignoring the tension crack, it means this whole part is equal to 0. And this angle we have here is going to be our normal theta. So that's the reason why we are using this particular formula. Since we are ignoring the tension graph, that means we are not using this formula. And it simply means this particular part that we added to Wx is 0. And this theta c is theta.
So where we are not ignoring the tension,
Yeah, that's the big part of the question. We'll still come back.
we'll see use it.
Yes, we are still going to use it.
Okay. Now we are ignoring the
Tension graph, because that's what the A part says we should do. From the question, we C was given as
19.0.
no, C was given as 42
Okay, 42
kilopascal. Yes.
RPC.
Then we know our R as 17.43. Our theta was given as 84.
84.06.
0.06 degrees. Then our x was given as, it's in the question, 6.54.
That's the distance between
Yeah, the distance from here
here to that place.
yeah,
Can you indicate it in the drawing?
and it was given as 6.54 meters. So what else are we looking for? W. We don't know it, but we know this one as 19. And we also know our A. Our A was given in the question as what?
You get right?
Yes. 102.1 meter squared.
Yeah, 102.1
meter squared. Yes. So, and whatever it is we are doing, remember we are doing it per unit length. So our unit length is going to be 1. By the time we are saying, by the time we are looking for our W, which is, I believe you remember this formula. Yeah, because it's actually times 1 unit length. Yes, it's per unit length. So from here now, our W is equal to 19 multiplied by 102.1.
multiplied by 1.
Yeah, multiplied by 1.
That we must put it.
Which gives us 1939.9. And the units. So we've gotten everything we need for this question now. So all we just have to do is to substitute it into the formula.
Sorry, sir. Before you go, the theta is, I want you to still convert to radian.
Yes, we are going to convert to radian. So can I erase this? So our factor of safety now becomes our C, 42 multiplied by R squared, 17.43 squared, multiplied by our theta, that's 84.06 multiplied by pi, then divided by 180. This all over W 1939.9 multiplied by x 6.54. What does that give us?
So then,
1.48. Do you have any answer that is different from that? B now.
the factor of
Determine the factor of safety.
determine
The factor of safety. You can just put F. Against immediate shear failure along the slip cell. Shear failure along the slip cell. If the tension graph is empty of water, if the detention crack is empty of water, and theta C equals to 67.4 degrees, then 67.4 degrees. A equals 71.64 meters squared, and X equals 5.86 meters. Now from the diagram, initially it was from here to here, from this whole part to the end of the slip circle here. But because we are now considering the tension crack, the area has changed. So the new angle is now between this place and the end of the crack. So that means the area will also reduce. Yes, since the angle has reduced, the area will also reduce.
Now the area of the sector.
Yes, the area of that particular slip circle.
So that means it moves up to the crack.
Yes, up to the crack.
And we indicate it in the dotted line.
Yes. So the area, you might not see A equal to. It's possible you see the area of the slip mass. Instead of writing A equals to, you can see area of the slip mass. So you already know that area of the slip mass means area. So and for the X, you can say central distance from O. Central distance from O. Yes, that's it.
So even the central distance we adjust, everything we adjust.
It will definitely adjust this. So the only thing that is not adjusting is our radius. Our radius will not adjust, it's still the same radius. So with that given, let's find out what our answer is going to be. Let's be.
First, suppose there's water in the crack.
That's
To attract another formula.
it's still going to be the same formula. For this particular one now, there's no water inside the crack. It means this one is going to become 0. So and once this one is 0, it's going to affect this one. So it will change back to our initial formula. So that's what I'm about to write out. Equal to CR squared theta C divided by WX plus EWYC. So when the crack is empty of water, EW equals to 0, then the factor of safety becomes CR squared theta C divided by WX plus 0. So it's going to become CR squared theta C divided by WX. So from here now, our C is still the same, still the same position. Our radius is still the same. Our theta C has been given as 67.44. Our W is going to change. No, our W is going to change. We need to find our W now. Then our X has also changed. Do you have a question, sir?
Yes.
Okay. So let's find our W. Our W equals to gamma A, right? And our A has been given. Our gamma is still 19 kilonewtons per meter cube. Per meter square. Yeah. So then our W becomes this multiplied by A. That's 19 multiplied by 71.64. 19 multiplied by 71.64.
are trying to find our W now.
Yes, I want to find out W. 1361.16
16.
kilonewtons. So,
That's the new W.
yeah. So I think we already have everything we need. Our C is still 42 kilopascal. So we can move on from here to get our factor of safety, which is going to be 42 multiplied by our radius has not changed, 17.43 weight multiplied by 42 multiplied by 17.43 weight multiplied by our new angle is 67.44, right? Multiplied by theta divided by 180 all over our W 13.16 multiplied by x, which is 5.6. Yes. So our factor of safety equals to. So 1.68. Is there any other contrary value? So now let's go to the third part of the question. Determine the factor of safety against immediate shear failure along the slip circle if the tension graph
the
is
C?
yeah, the C.
Okay.
Determine the factor of safety against immediate shear failure along the slip circle if the tension crack is full of water. Here now,
I'll share this.
so this question, the parameters are going to be the same with that of the B part. Everything we are using is still going to be, the area is going to be the same, the radius is the same, theta C is also the same, W is the same, X is the same. The only thing that is going to be different is that we need to find the EW and YC. So, like we said, YC is the distance from here to this particular point. From here to 2/3 of Z naught or however it is. So our Z naught is given as 2C over gamma. This is C, 2C over gamma. Yes. So which is equal to 2 into our C is 42, then divided by 19, which is so that one is 4.42. And like we said YC is equal to this 6.7 plus 2/3 of 4.42. Yes. So YC equals to 6.7 plus 2/3 into 4.4, which is equal to what? Rho W. Is somewhere around here, Shai. It wasn't indicated, but there was places somewhere around there.
I think you got that question.
From the question, yeah.
So in the typical example, this indicated
No, we just need to find it.
no, the type of method to use in analyzing the slope. I think this will
Yeah, from the question, you'll be able to tell. So, like this one now, once you are hearing tension cracks, then you definitely know that, okay, are we ignoring it? Or are we going to, or are we not ignoring it? So once it says we are ignoring it, automatically we are using Taylor's method. Then if it says we are not ignoring it, then we come back to this. Then another thing is whether the tension crack is filled with water or not. If it's filled with water, automatically this one too is going to go out. But our theta C will still remain. So then for Swedish method of slices, once we see the parameters that were given, then we should be able to tell that this is what we have to do.
When outside the Taylor's method, which other method are you referring to?
Taylor's method, Swedish method.
No, this particular formula now. See, when you don't use the
6.5.
Yes. If we are ignoring the first one, it's going to be CR squared theta over WX, which is still the Taylor's method.
one of these other ones is complete.
This one that is complete is the modified Taylor's method. Yes. 9.6 should be something small. 9.6 5 meters. So the next thing for us to find is this. Yeah, this EW. Well, actually, I believe this one should be, instead of EW, I believe it should be rho W. I don't know if I'm right. Yeah, it should be rho W because I actually wrote it down in 7 minutes. So even if it's E or rho, the good thing is just to get the formula right. 9.64, 9.65. So is this part clear? Is there any question on this part? These two parts before we move to here. For our rho W now, it's plus. So for this is the same thing as 1 over 2 rho W multiplied by Z naught.
If the federal crack has water,
Yes, exactly.
I will not start it.
Yeah, we'll start playing this one.
That EW.
Yeah, either EW or rho W, anyone. Right. Let me just pass EW directly. So we know this, and we know this. Although this one wasn't given, but we know that it's 9.81. Yes. So we can now say it's equal to 1 over 2 multiplied by 9.81 multiplied by our Z naught for comfort. Wait. So which gives us what?
Yeah, that's the problem.
From here now, I believe we can do this one like this last part. Because we have
we just slot in the wires.
Yeah. So can we do it and tell me what you have?
Okay.
So how many of us have gotten the answer as 1.6 now?